spreadsheet that is pretty much going to do the work for you as long as you put the right numbers in here. So you got to be careful of how to do this, okay? So I named this as manhole 1, pipe 3, manhole 4, pipe 2, manhole 5, 6, 3, storm, and sanitary. I'm going to do storm with you, and you do sanitary on your own. Now, the manhole number we have in our drawing. So if I go here on my Autocad drawing, I have here my manhole 6, my manhole 5, manhole 4. I know where they are because we named them before. But how do I know the pipe? Which one is pipe 3, for example? I put it here. You see here on the bottom diagram, if you click here, you're going to have this small drawing over here. So for example, I know that pipe 3 is the pipe between manhole 1 and manhole 4. So when I need to enter the diameter, the slope, and the distance of this pipe 3, it's going to be the line that we have between manhole 1 and manhole 4. Is that clear? Yeah? So let's do it together one here. For manhole 1, which is the first manhole that we have here, if I go into this spreadsheet elevation calculation here, I have the US elevation and DS elevation. US means upstream, DS means downstream. So downstream is the pipe coming out, which is going to go to the existing sewer over here. So this manhole over here, we have 2 upstreams and 1 downstream coming here. So these pipes are coming, this is coming, and this one is going this way over here, bringing everything that receives there. Okay, I'm talking about this one now. Sorry, this part. In here. So what is the downstream elevation? It's provided on the instruction. So if I go here, do you see in manhole 1 storm downstream elevation? Now I have this elevation over here, 310.80, which means that inside of that manhole, there's a pipe coming out, okay, which is called the downstream, and the elevation of that pipe over here, the bottom of that pipe, is going to be 310.80. Does that make sense? So look what I'm going to do with my Excel spreadsheet here. I'm going to come here, and I'm going to put the downstream elevation 310.8. Cool? Now from this pipe, from this manhole over here, I have an upstream elevation, which means that I have pipes arriving there that are larger than this one, are going to the different direction of this one. So before I connect these pipes, they need to have a drop. There is a difference in elevation of the pipes coming in than the pipe coming out. How do we know that? On the instructions over here, I provided this to you. On manhole 1, which is this one over here, I'm going to have 2 drops. The drops going north and the drops going west. And how do I know it's north or west? It's because on this direction over here when we have our regular UCS, okay? This is going to be north, this is going to be west. So if I go here and I see the drops of this manhole, I go here, the drop, it needs to be 0.15, do you see? Which means that the pipe's coming in, okay? This line over here, and so the pipe coming out, I need to have a difference in elevation there of 0.15. Does that make sense? Yeah? So the pipe that comes in and the pipe that comes out of that manhole, they need to have a difference of 0.15. Is that clear or not? Yeah? So luckily it's 0.15 in both ways, this way and this way. So look what I'm going to do here. The center line, this one I'm going to put after. Now the upstream elevation is going to be this one over here plus the 0.15. So how much is 310.8 plus 0.15? 0.15. Oh, so 0.95, right? So downstream elevation is this one, upstream elevation is this one. Center line distance. Look what I need to put, what information I need to put there. I need to make a line from the center of my manhole perpendicular to my center line here, and this distance over here is the distance that I'm going to put in there. So the perpendicular distance is 2.36, for example, in this one. So manhole 1, the center line distance, 2.36. We also call this the offset, okay? We are going to need this information to put on a label for our manhole, so it's important that you label it here. Did you understand what we did here? The downstream elevation was provided to you. Then we need to know what is the minimum difference that I can have from that pipe to my next pipe. And based on the drops provided, it's 0.15. Later you're going to learn that these drops over here vary depending on the connection of the pipe. If it's a 90-degree connection, it's going to be one number. If it's a 45-degree connection, it's going to be another number. You're going to learn about those standards later. Okay? Here what is important is The drop north is 0.15, the drop east is 0.15, so I added 0.15 here, my downstream is this, plus my drop, I have this information over here, and this is the center line information. Did you understand how I filled these numbers over here? Everyone? Any questions? Yes?
The downstream, which you had that.
I get on the instructions. So in here, I provided on this table over here, manhole data, that the downstream for manhole 1 is 310.8. Okay? And this we cannot change because the pipe needs to go to the existing storm drainage. So we cannot change this elevation. Now everything else that we draw here needs to depend on this elevation over here. So when it gets back, it will go to the existing sewer. Does that make sense? Because if we start the other way around, maybe we get there, and if this elevation here is higher than when we arrive with the pipe, what's going to happen with the water? No? So we need to get, this is the lowest that we can have, and now we're going to start going from this elevation to draw our pipe. So 310.80 plus the drop 0.15 upstream elevation. Now we're going to go to pipe 3. Pipe 3 is the pipe between manhole 1 and manhole 4. Okay? So I'm going to go here to my drawing. The pipe 3 should be this one over here. The pipe between manhole 1 and the pipe between manhole 4. And this, in my drawing, it has 65 meters, it's 450 millimeters, and it's 1 EF percentage. So look what I'm going to do here. Let me divide this in two screens. I'm going to come here, this is my pipe 3. What is the length of my pipe 3 in my drawing? 65. Your ones might be different, depending on where you place your manhole. So make sure that you get the distance of the pipe that you have in there, okay? My slope is 1 EF. I'm going to pretend my EF is 1.3. So 1.13 is my slope, based on my student number over here. And the diameter of the pipe is 450. What does this give me? It gives me that my pipe is arriving at this manhole, the out elevation, at 310.95. And based on this distance, and based on this slope, it's going to arrive in my next manhole at this elevation over here. Does that make sense? Yeah? So again, it's leaving this manhole 1 over here at this elevation. Based on the distance, the length of the pipe, and the slope that I have, it's going to arrive in my next manhole, manhole 4, at this elevation over here. Does that make sense? Now from manhole 4, I'm going to have another pipe. If I look into my diagram over here, after I have manhole 4, I'm going to have my pipe 2. Does that make sense? Now my pipe 2, it's not going to leave at this elevation over here. I need to have a drop. And this is what I'm going to input into this table over here. First of all, manhole 4, how far is it from the center line? I'm not going to measure it because I know it already, it's 1.5, but you guys could draw a line here and measure that distance there. So 1.5 here. Now what is the drop for manhole 4? I'm going to go here. Manhole 4 should have a drop of 0.05. You see here? Now once I put the drop here, I want you to pay attention to these numbers over here. This is the elevation that the pipe 3 is coming into manhole 4. This is the elevation that pipe 2 is getting out of manhole 4. As of now, they're the same. Do you see this? Once I insert my drop here, the elevation out is going to be different. So the pipe coming this way, then there is a drop, and then the next pipe continues. They don't arrive on the same elevation. Does that make sense? Every elevation that we have here is based on the center of the manhole. I'm gonna show you later how does that work in Autocad. Did you understand how I put manhole 4 over here? Yeah? Easy? Let's go to pipe number 2 then. This is gonna be pipe number 2. And if you wanna make sure, you can click here, and you see that pipe 2 is between 4 and 5. And pipe 2 is gonna be, I need to open my Autocad. My pipe 2 is also gonna be 65 meters, in my case. So 65 here. The slope here is going to be 1 EF, which is the same as before. So I'm going to say 1.13. And you see that it shows 1. It's just because it's rounding, but the number here is actually 1.13. Okay? Now the diameter of this pipe, it's going to be 450. It doesn't really affect my drawing over here, because this is 450. And this is the in elevation, the out elevation from manhole 4, and this is the elevation that it's going to arrive in manhole 5. Now, at manhole 5, it arrives at that elevation, then the center line distance in here is not going to be 1.5, so I'm going to draw a line here, perpendicular to this, and I'm going to say DI enter from here to here, 3.22, 3.22 here. What is the drop for manhole 5? I need to go into this drawing. The drop for manhole 5 is 0.15. You see that? So what I'm going to put here, 0.15, and what I'm going to have is, this is the downstream where the pipe 2 arrives, and this is the upstream where the pipe 1 arrives. So the pipe 1 arrives at this location, the water falls in there, and then it's going to continue in this location over here, at this elevation over here, which is pipe 2, which is the difference of them is the drop. Make sense or no? Yeah? Now I'm going to do the last one, pipe 1. The length for pipe 1 is 89.03 in my case, 89.03. 1.gh, I'm going to say that it's 1.17 based on my student number. I'm just randomize that. 317 is right here, and that's what I have. And then I'm going to have manhole 6, which doesn't have a drop. It's just a simple number over here. So I just need to grab the center line distance. Which one is going to be? 1.5, right? Because it's exactly straight.